Okay, today we're doing polynomial functions. So functions means that we are still using our graphs, and we're just going to look at our graphs and learn a whole bunch of different things about them. All right, poly means many. Like a polygamist has many wives. Poly means many. That's the only example I can come up with poly in it, besides Polly wants a cracker. All right, nomial means terms. So we have a many-termed function here. Now, this purple line right here looks really confusing. And you're just like, what? But this is simply saying that a polynomial is in this form. It's some function where we have a whole bunch of terms, and the terms go down in order. In other words, if the highest exponent is n, then the next exponent is 1 less, and we keep going down and down and down and down until we have no variables left. So this is examples right here. A quadratic function, better known to us as a parabola. All right, so if you see right here, it goes an exponent of 2, an exponent of 1, and then this last guy right here, this a sub 0, notice there is no x term there. With our cubic function, it's the same way. By now you kind of figured out cube means 3. So the exponents go in order 3, 2, 1. And then this has no exponents, x to the 0. And then a quart, which means 4, 4, 3, 2, 1, none. So that's all this is saying up here. Don't get afraid of it. All right, let's just get rid of some of this stuff. So we're just going to be looking at these different types of functions today and answering some questions about them. And for the most part, they're pretty simple. All right, a quadratic function, as we told you, is a parabola. So quadratics are going to have this shape. A cubic function is going to look like this. And a quart function, or something that's raised to the highest power of 4, is going to look like that. Now, if I were to put negatives in front of these things, so let's clone that. And then let's just put a negative in front of that. What happens? Basically, it's the same. It's just upside down, because that's what a negative means to do. Same thing right here. If I clone that, put a negative in front of it, then this cubic function gets turned upside down. Whoops, let's do it. Upside down means like this, sorry. Let's go flip that, left, right. That would be upside down for a cubic function. And then this quart, you get the same idea. All right, so what are we going to do with these? First new word, onto. That looks like 1 to 1, but it means something different. Onto. A function f from a to b is called onto if for all b in set B, there is a in set A such that f of A equals B. What? It's really simple. Think about getting picked for a team. Are you on to the team? So up here, R got put onto team 4, H got put onto team 2, O also got put onto team 2, and Q got put onto team 5. Over here, R got put onto team 4, H got put onto team 2, Q got put onto team 5, but nobody got put onto team 1 or team 8. So their team rosters are not full. There's nobody onto those teams. And we always work with the range. We want to see is all the range being used. In here, we only had 3 people in the range, 4, 2, and 5, and they were all being used. Somebody was onto them. Here, we have 4, 2, 5, 8, and 1, and 2 of them are not being used, the 1 and the 8. Nobody's onto them. So if you don't want to think about it as a team, think about it as getting away with something. Nobody's onto them. Nobody sees that they're hiding there. All right, so however you want to remember onto. A root. A root is where the function crosses the x-axis. Sometimes they call it the zeros of the function. And this is nothing new. This is what you've been doing since freshman year. No, 8th grade. Remember when we asked you to factor x squared minus 9? And you went, oh, that's okay. It's a difference of 2 perfect squares. And this is what I get. And so my answers are 3 and negative 3. Well, that's the root. That was where this quadratic crossed the x-axis at 3 and negative 3. Okay, so what's the homework going to be like? What is the whole point of this lesson? What are we trying to do? We're trying to point out all these new words. So let's look at this. Hopefully when you look at this picture, that's right, you say, oh, that's a parabola. That is a quadratic, same name. Okay, find the roots of this. Roots are where it crosses the x-axis. So here's my x-axis, and it crosses at 1, 2, and 1, negative 2. So the roots are 2, negative 2. Domain. Okay, so domain are my x values, and I'm going to use this line to help me do that. So my x values. Will this quadratic eventually cross every x value? Yep, well, it crosses the x value of 1, of 2, of 3, of 4, of 5, because it would really go all the way up there. So this domain is all reals, which we can either write as such, or we can write the calculus way. The range. Well, the range goes this way. So the range, if I look, the lowest value that this graph hits is 1, 2, 3, 4, negative. So the range is, it hits negative 4, and then it goes up forever and ever. That's the calculus way to do it. Or you could say all y values greater than or equal to negative 4. This parabola is going to cross. Is the function onto? Remember, onto, we look at the range. Does this quadratic cross every possible value in the range? Is this quadratic onto every range? No. Right here. See, negative 5, it's not crossing negative 5, so it's not onto every possible range. Is the function one-to-one? Well, it's already telling us it's a function. It's using the word function. So we know that it passes the vertical line test. Whoops, wrong thing. Let's grab this one. We know it passes the vertical line test because it says function, but is it a one-to-one function? No, because it doesn't pass the horizontal line test. All right, looking at this one. Hopefully, from the beginning, you realize that it is a cubic function. That means it is the form x cubed plus bx squared plus cx plus d. All right, find the roots. Okay, so where does it cross the x-axis? Well, unfortunately, the problem that I gave you, I couldn't get really precise with. I just couldn't think of a nice one off the top of my head. So we're going to have to estimate here. I know that's a bad thing, but it looks like it crosses there, there, and there. You'll learn how to find the exact answers, but just not today. So if we look at that, we say the roots are -2.5, it looks like, -1, and 1/2. Okay, what is the domain? All reals. What is the range? Well, this range is all reals, because it looks like it's going to pass through every possible real number. If I do my real test, yep, these are all my reals. 6, 5, 4, 3, 2, 1, 0, -1, -2, -3, -4. It passes all of them. Is the function onto? Will it pass onto every possible range? Yep. So this is onto. Is it 1 to 1? No. Whoops. Let's get that out of there. Why is it doing that? Get away. Right here is where it fails the 1 to 1. So it is not 1 to 1. And it already is telling us it is a function, so read carefully. It didn't ask us if it was a function. It already told us it was a function. Okay? Find the roots. Well, if we look over here, believe it or not, this is a quartile function. It looks like a W. Really, right here. W. I know it doesn't, but it is. So the roots, it crosses here at 3 and here at -1. Now, it really should cross 4 times because it is to the power of 4. So that means it should cross the x-axis 4 times. It has what we call double roots. This root is really appearing twice, and this root is really appearing twice. And you're like, no, it's not. I only see them once. We'll get into that further on. But right now, we just want you to realize what a root is, where it crosses the x-axis. Is the function onto? Well, I couldn't really get one to show you, but it is not onto, because we know that as a quartile, it's got to go down, it's got to hit some low point, and that it's got to come back up. So it is not onto, because it doesn't hit all the range possible. Is it 1 to 1? No, because it fails the horizontal line test. Okay, just a quick review. All right, we have a quadratic over here. This is the mama function, and the mama function is y equals x squared. I know it's the best I can draw a parabola. Sorry, not the greatest artist. So now what they're asking us, could you quickly draw what would x squared minus 4 look like? All right, so let's clone this out. All right, so come on out. There it is. And let's change its color to green. And x squared minus 4, since the 4 is outside of the parentheses, I'm going to go down 1, 2, 3, 4. And that's what x squared minus 4 would look like. Okay, let's pull this one out again. Let's change its line color to blue. And what would x squared minus 4 look like now when the minus 4 is inside the parentheses? Well, we know when it's inside the parentheses, I'm moving along the x-axis, and I'm going to go to the right 4. 1, 2, 3, 4, because when it's inside the parentheses, I do the opposite. Let's pull another cloner out here. This time we're going to make it yellow. And plus 5. And I am inside the parentheses, so that means I'm moving on the x-axis, but I'm moving in the opposite direction to a plus 5. So over here at minus 5. And the last one, let's change that one to gray. And it asks me what would x plus 3 look like, but the plus 3 is on the outside of the parentheses, so I know I'm moving on the y-axis, and I go up 1, 2, 3. And there's Mama and all her babies. What a beautiful family portrait. Okay, bye.